Welcome to online lecture series in organic chemistry, and we are discussing the electronic spectra of complexes. In earlier video we have discussed about the determination of ground state term for D2 configuration. Now in this video we are going to discuss the Hund's rule for determining the ground state term for D2 configuration, or determination of ground state term symbol for D2 configuration on the basis of Hund's rule. Now according to Hund's rule, you know that the term with maximum spin multiplicity is most stable and have a least energy. For a given multiplicity, the state with highest L value is most stable, and for given S and L values, term with smallest J value is most stable if subshell is less than half filled, whereas the term with highest J value is most stable if the subshell is more than half filled. So based on these Hund's rules, we are going to find out the ground state term symbol for D2 configuration. So these are the possible terms on the basis of selection rules for D2 configuration, that is G1, F3, D1, P3 and S1. And possible term symbols are for D2 configuration G1 4, F3 4, F3 3, F3 2, D1 2, P3 2, P3 1, P3 0 and S1 0. So these are the possible term symbols. Out of various term symbols, one term symbol, it is the ground state term symbol, means have a least energy, and other term symbols are the excited states, and altogether there are 45 microstates. So all these we are going to identify in this video. Now for D2 configuration, three multiplicities are possible: triplet and singlet. You can see here 1 3 1 3 1. So triplet and singlet, some of the term symbols are classified in triplet state and remaining term symbols are classified under singlet. So, and as per Hund's rule, triplet is most stable than the singlet, and therefore triplet have lower energy and singlet will have little bit higher energy. Now in triplet there are two terms, F3 and P3, and according to second rule, that is for a given multiplicity, the term or state with highest L value is the most stable. So out of F3 and P3, F3 will be most stable. For F term symbol or term, L value is highest, and for P3 it will be lowest. So triplet, again there are two triplets, F3 and P3. F3 will have lower energy and P3 will have higher energy, because for F term L value is more as compared to L value of P. So this is about the LL coupling. So triplet and singlet, these arises as per SS coupling, and terms arises as per LL coupling. Now in singlet, again there are three terms, G1, D1 and S1. These are the singlet terms, but again these singlets are as per LL coupling, the term with highest L value will have the lowest energy, and out of SDG, G term will have highest L value, then D and then S. Therefore singlets, there are three singlets, G1, D1 and S1. So in this way these are the terms arranged as per the energy difference. F3 term have lowest energy and S1 term will have highest energy. So this is as per the LL coupling. Now next part is the LS coupling. On the basis of LS coupling, these terms further split into the term symbols. There is a LS coupling. Now you know, for F3 term there are three term symbols, F34, F33 and F32. Again, as per the third Hund's rule, for a given L value, the smallest J value is the most stable, or term with smallest J value is most stable if subshell is less than half filled. In D2 configuration, subshell is less than half filled. Okay, and therefore out of F34, F33 and F32, so F32 term will have lowest energy, then F33 and F34, and therefore F terms after LS coupling, these will split into the three term symbols, that is F32, F33 and F34, and F32 term symbol will have lowest energy because its J value is least among these three. Now for P3 term, again there are three possible term symbols, P32, P31 and P30, and as per the Hund's rule, again P30 will have the lowest energy, and this is about the splitting of P3 term into the three term symbols, P30, P31 and P32. Okay, so now for G1 term, there is only one term symbol, that is G14. So only one electronic state will be there. Again for D1 term, there is only one term symbol, D12, and for S1 term there is only one term symbol, S10. So this is about the arrangement of term symbols as per the energy states or energy levels. Now we are going to identify the microstates. There are 45 microstates. So here S10, this is after JJ coupling, it will give the only one microstate, that is energy state. So there is only one mj value possible for S10 because j is equal to 0 and value of mj ranges from plus j to minus j, that is plus 0 to minus 0 means 0. So only one energy state is possible for S10. Now for D12, value of j is 2 and j value, it is 2j plus 1 fold. As per this formula, when j is equal to 2, then 5 mj values are possible, and these 5 mj values are plus 2, plus 1, 0, minus 1, minus 2. So these are the 5 energy states or microstates for D12. Similarly, G14, this term symbol split into 9 microstates or energy states, because this is the 4 j is equal to 4 and possible j values are plus j to minus j, that is plus 4 to minus 4, or 9 values are there, and these are the 9 energy states for G14. So plus 4, plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3, minus 4. These are the 9 microstates for G14. Similarly for P32, as j is equal to 2, 5 microstates or mj values are possible, that is plus 2, plus 1, 0, minus 1, minus 2. 5 microstates are possible for P32. For P31, 3 microstates or mj values are possible, that is from j is equal to plus 1, 0, minus 1, or mj is equal to plus 1, 0, minus 1. Similarly for P30, there is only one mj value, that is 0. For F34, 9 values are possible, plus 4 to minus 4. For F33, 7 values are possible, that is from plus 3 to minus 3 through 0, that is plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. 7 mj values or microstates are possible, and for F32 again 5 mj values or microstates are possible. When we take sum of these microstates, then it is 45. It means altogether D2 for D2 term 45 microstates or energy states are there, and these are the corresponding mj values. Now out of various term symbols, F32 term symbol, it is the ground state term symbol because it has the least energy and the most stable, whereas other term symbols are the excited states or excited term symbols. So this is about the identification of ground state term symbol for D2 configuration as per Hund's rule and the corresponding microstates. Now the alternate method for determination of ground state term symbol for D2. Now configuration is D2, so 2 electrons accommodated in D level, and these are the ml values for 5 orbitals. ml is equal to +2, +1, 0, -1, -2. So for first electron ml value is +2, and for second electron it is, for example, +1. So L, it is the summation of ml values. For first electron ml value is +2, and for second electron it is +1. When we take sum of these two values, then it is 3. So L is equal to 3 means it is F term. Then resultant spin quantum number, there are 2 electrons spinning with clockwise direction, spinning along the clockwise direction. So plus half, that is equal to 1. So this is the value of S. So S is equal to 1, L is equal to 3. Then as S is equal to 1, spin multiplicity will be 3. As per this formula, that is 2S plus 1. Here value of S is 1. So 2 1s are 2 plus 1, that is 3. So this is the spin multiplicity. So value of J ranges from L plus S to L minus S. So L is equal to 3, S is equal to 1. So 3 plus 1 2, 3 minus 1, that is 4 to 2, and possible J values are 4, 3, 2. Out of these 3 J values, the allowed value is 2 because the subshell is less than half filled. 2 electrons are there. So as subshell is less than half filled, J is equal to 2, and therefore the ground state term symbol, it is F3. 3, this is the multiplicity, and 2, this is the J value. And this is the alternate method to find out the ground state term symbol for D2 configuration. So in this way, here we completed the determination of ground state term symbols for D2 configuration.